Hi, and welcome to the chain rule, that thing we've been putting on for quite a while now. The approach I've taken on these videos is to start you guys off with derivatives and show the very basic ones, the ones that don't need the chain rule. Because the chain rule I know is really confusing for students. That's like one of the first things I see usually in calculus, because that's what, if somebody's sort of having trouble with calculus, often the sort of straw that broke the camel's back, gets them to call a tutor, me, would be when they get the chain rule, because then it becomes just like, wow. And the way teachers usually teach this is the reason why. Usually they start with a bunch of theoretical junk and they tell you how like dy du times du dx or something, and these cross cancel. I don't know. Anyway, so the way they teach is really mathy. But I want you guys to see is that chain rule is just derivatives. It's the same formulas we've been using. We're just going to throw a u prime on the end. So like everything else is just in the noise. What really matters is that we're going to throw a u prime on the end. So in this video, I'm going to show you just roughly how we're going to do this and show you some of the problems, new problems versus old problems, how to spot when you need the chain rule. And then the following videos, we'll go through each of the derivative rules and each of the derivative types, like polynomials and roots and all that. And we'll really do a lot of examples of the chain rule on each type of problem. We'll show you how the formulas are different between before and after the chain rule. So we're totally going to get locked in on the chain rule. This video is going to just show you, hey, like, how do you spot a chain rule problem? Why do we need this thing? And start getting you familiar with this whole u prime deal they've got going with the formulas. All right, so here's a bunch of formulas, and these should look familiar to you. So we've got, the old power rule. If we had something to the power of n, the derivative is the old exponent times the same thing to the new power, which is 1 less. So take away 1. But then this is the new guy, right? This u prime on the end, where'd that come from? Well, that's what's going to allow us to take the derivative of stuff other than x to a power. Same thing happens with sine and cosine. Derivative of sine is still cosine. The difference is that we got a u prime on the end. Cosine, same deal, got a u prime on the end. And then, of course, e to the u. Once again, its derivative is just itself, but we've got a u prime on the end. So now let's take a look at what is u and what is that u prime we're going to end up with. All right, so here's some power rule problems, sort of with the chain rule and without. So before, these are the problems we worked in the derivative of power rules video. You can take the derivative of x cubed. You can take the derivative of third root of x, cube root of x. And of course, this just would have been 3x squared, and this would have been, I don't know, we'd convert it to x to 1/3, blah, blah, blah. You've seen that in the video. But check this out. We do need the chain rule for this problem, because here we've got something, a bunch of stuff, in this case a polynomial, raised to a power. So we still want to use the power rule. And we'll get into this in the next video, but the derivative of this is going to be like your typical power situation. You take the old power, put it out front, and then we're going to keep this stuff the way it is. Then we'll have a new exponent that's 1 less, so it's 2. But then we're going to have to multiply by the derivative of the stuff inside. And that's the thing that the chain rule adds, and that usually when students get a problem like this wrong, the problem is forgetting that u prime. U prime is super important. Same thing here. Here's another one we could not do before, the chain rule. We've got a cube root, which we already knew how to take the derivative of, right? We did one right up here. That's just a typical cube root also. Except this one, instead of being a cube root of x, it's a cube root of a big polynomial. Well, there's a polynomial under the root. Got to use the chain rule. So we're going to end up with some extra junk on the end of our answer. All right, here's some trig formulas that did not need the chain rule. Sine x, cosine x, secant theta. These are all, the big deal is that after the sine or cosine or whatever, there was always just a single letter. We got an x, we got an x, we got a theta. Could have been a y, whatever, but there can only be one letter without the chain rule. With the chain rule, now we can do 3x, which I know didn't seem like a big deal. A common mistake students make is that they want to just take the 3 out, kind of like factor out the 3, but that's not legal. So it turns out you actually do need the chain rule for this thing. And same thing for here. Now this one has this kind of a double whammy, and this will get into the really hard problems. One problem, or one reason we can't do the this problem without the chain rule, is that it's not just the sine of x, it's the sine of 5x squared. So right away you should be thinking, oh man, I need the chain rule. But it turns out this isn't really a sine or cosine problem. This is really a power problem, because we've got the sine to the third power. Now these ones are a little bit confusing, so I'll bring it up now, and then of course we'll see it in a later video about trig functions and the chain rule. But this is really a power problem with a really fancy innards. Because you know how on a sine or cosine, if I want to write sine squared, or sine of theta quantity squared, you know, I want to square the sine of theta. You know how you always put the 2 in kind of this weird place? And the reason you do that is because if you wrote it like this, sine theta squared, that means something else. This means the sine to the first power of theta squared. So that's why they put the exponent in this kind of weird gap between the sign and the variable. Well, that's what's going on here. So this problem down here is actually, you can think of it as the derivative of sine of 5x squared, and then this whole monster being cubed. So doesn't that actually make it look like a power problem with a lot of really fancy junk inside? That's the kind of, you know, sort of deciphering we're going to have to do on these problems to figure out which rule to even start with. You know, which of these massive problems that we're going to use a chain rule once or twice and have to use another formula or two as well, which one's the first one you use? You know, is it a power rule first? Is it a sine or cosine first? So we'll get into that big time in the upcoming videos. All right, so last one we're going to look at, exponentials. Before, it was always just e to the x or 5 to the x or a number to the x. But the point is the exponent had to be x. Or it could have been y or something, but it had to be a single letter without any exponents on it. But now, we're going to be able to do the ones that are much more common in math, which is stuff like, you know, you have a big polynomial as the exponent of e, or you have, in this case, a pretty nasty one, the exponent is a sine function, which itself is going to require the chain rule. So this is going to turn out to be sort of a nasty nested chain rule problem. We have to do the chain rule once and then again, and that's going to get crazy, but you know, that's why people call tutors for the chain rule, because it gets confusing, like how many times do you have to use the chain rule in one problem? Sometimes it's 2 or 3 times. You know, if you have a nasty class, like a hard class and a pretty hard teacher. All right, and of course we can even go crazier than we just saw. Here's an exponential with a massive polynomial to a power, which means and it's the sign of this, right? So we're going to, on this particular problem, this is one of those nasty ones I was talking about, you're going to start out with the derivative of sine being cosine, but then when you do your u prime on that first chain rule, you're going to have an exponential with its own chain rule, but then that exponent's going to need the chain rule because it's a power. Super crazy problem. Similar thing's going to happen down here. All right, so stay tuned for this chapter. If you have any trouble with the chain rule, like if you're definitely sort of confused and lost in the chain rule, if I were you, I'd watch each video in this chapter in order, because even if you think that you go to the polynomial chain rule, but just not with sine and cosine chain rule, the chain rule really builds, and by doing tons of examples and seeing me work all those examples, you'll sort of start to get a feel for how to approach these problems. Because it might turn out that even the ones you think you already know how to do, you don't quite, you know, you're not quite as solid as you think you are. If you're way more solid on that particular type, you might be able to see better how to do the harder ones you know that you're having trouble with. And as always, practice, practice, practice. You know, you should be working these problems along with me. Better yet, whenever we slip to a new slide and see a problem, pause the video, try and work it on your own, and then see if you were right. If you find an error in the video, obviously email me with the contact form. Hopefully that doesn't happen. But you know, these are tough, these are messy, and just like you might drop a negative sign every once in a while, it's been known to happen to me as well. So stick around, I'll see you in the next video.